if I've got some pent-1-ene, and let's just make sure we name that correctly. We have 1, 2, 3, 4, 5 carbons. There's only one chain here. And our double bond is right on the number 1 carbon, or we'll make this the number 1 carbon because it's the closest to the double bond. It's better to start counting from the left end than the right end. So this is right here, pent-1 ene. But in this video, what we want to do is figure out what will happen if we start with some pent-1-ene, and to that we add some hydrogen bromide. We add some hydrogen bromide. And to think about this, and what we're going to do, this is actually the very first reaction mechanism we're going to do. But really, most of organic chemistry is all about reaction mechanisms. And it's all about getting a sense for what is likely to happen, or what is a reasonable reaction. We'll learn a set of rules, and hopefully we'll get an intuition for how things work. So we're doing a reaction mechanism here. Reaction mechanism. So a good place to start is to just think about what's going on at the hydrogen bromide level. And to do that, let's look at the periodic table right here. So we have hydrogen sitting up there, and then we have bromine sitting all the way to the right over here. And we learned in first year chemistry that things are more electronegative as you go to the top right of the periodic table. Things get a lot more electronegative. Electronegativity grows in that direction. Electronegativity. And just as a refresher, electronegativity just means the tendency for that atom to hog electrons. So you see bromine over here, you see hydrogen over there. Bromine is much more electronegative than hydrogen. So in a hydrogen bromide molecule right here, the bromine part of it is going to hog the electrons. So you're going to have a partial negative charge. You're going to have a partial negative charge at the bromine end, and you're going to have a partial positive end at the hydrogen end. And this is actually so electronegative that it's reasonable that bromine could completely steal all of the electrons. So let me draw that. So this bond right here, let me make this bond a little bit bigger. And this is, and I'll do the notation that people usually use when they draw reaction mechanisms. So this bond right here has 2 electrons. We're saying that bromine is so much more electronegative than hydrogen that it could altogether steal hydrogen's electrons. It could altogether steal a hydrogen's electrons and go on to the bromine. Now, if that happens, what will this whole setup look like? Well, if that happens, this whole setup, we'll move down a little bit. We'll still have, and I'll just copy and paste will be useful here. So we still have our, copy and paste that. We still have our pent-1-ene. But now, in the hydrogen bromide, the bond, you could view it as having broken up, because the bromine, which is now a bromide anion, will have taken the electrons. This is what that is showing. So let me draw that. And let me actually clear this out right here. Let me erase this right there. And so this over here will now look like this. The hydrogen is now just a positive cation. It's just a proton, really. So you have hydrogen with a positive charge, and then you have the bromine with a negative charge. Now that it's an ion, we would call it bromide. So we would call this bromide. It's sitting on a negative charge. And now what is likely to happen? Well, I have this alkene here, this pent-1-ene. It has this double bond, and in this double bond you have 2 electrons. Maybe one of these electrons will be attracted to the hydrogen, and then essentially making one of these 2 carbons, I guess you could view it naked on some level. It won't have all of its electrons anymore. So let's do that. Let's do that. And actually, we'll then think about which carbon is more likely to be the one that gives away its electron. So for the sake of this mechanism, let's just say that this carbon right over here, that this carbon right over here, that it is the one that loses its electron. So this bond right here, let me see, this bond right here has two electrons, one on this carbon, one on that carbon. The carbon on the right loses its electrons, and it goes to the hydrogen. And it goes to the hydrogen. It goes to the hydrogen. So then after that happens, what will the setup look like? What will the setup look like? So then we're going to have, so let me see how neatly I can draw this. Let me draw it. It's no longer pent-1-ene, it's something in between now. So you have your original setup, carbon, hydrogen, hydrogen, carbon, and then you have your CH2, CH2, CH3. This carbon had a hydrogen bond, but what we're saying is that this, one of the electrons here, this has two electrons in it, one on this carbon, one on this carbon. This bond goes to that hydrogen. So now it will look like this. Now it will look like this. It went and bonded to the hydrogen. Essentially, an electron went from this carbon right here, the carbon on the right side of the double bond. An electron went from that carbon and went to the hydrogen. Now the hydrogen is neutral. But what happens to this carbon? Well, he gave away an electron. He gave away an electron. He had 4 valence electrons. Now he'll only have 3. So now he will have a positive charge. So you can almost imagine that the positive charge went from the hydrogen to the carbon, although it didn't move. The electrons are what move. So now this guy is sitting with a positive charge. This guy is sitting with a positive charge. He would really like access to an electron. And we can't forget that we have our bromine. We have our bromine sitting there with a negative charge. Our bromine sitting there with a negative charge. Our bromine is sitting there with a negative charge. And if we want, we can actually draw its valence electrons. Bromine typically has 7 valence electrons, but it stole an electron. It has a negative charge now, so now it has 8 valence electrons. So we could actually draw it. So it has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Let me draw it over here too. 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. It has kind of 1 extra. That's what's giving us a negative charge. This carbon needs it. So why doesn't bromine essentially donate one of its electrons to the carbon? So why doesn't it donate one of the electrons to the carbon? And then when that happens, what are we going to be left with? What are we going to be left with? This is one of our final products. And in the next video, we'll think about what other product could we have here. So let me draw this. So bromine gives an electron, forms a bond essentially with this carbon, and then our molecule will look like this. You have a carbon. Let me write a little bit neater. Carbon, hydrogen, hydrogen. You still have that hydrogen now in orange. I want to make sure we remember where things came from. And then you have a bond to this carbon, which is bonded now to the bromine. It is bonded now to the bromine. And then all of the other stuff that it was bonded to before. You have a hydrogen, and then you have another chain of 3 carbons. Another chain of 3 carbons. So what we just did is we showed a reaction mechanism. We showed a plausible way to start with pent-1-ene and hydrogen bromide and get to, when the two things are mixed together, to get to what is this thing right here? Let's name it just for fun. What is this thing right here? We still have 1, 2, 3, 4, 5 carbons. It's now an alkane. There are no double bonds here. So we're dealing with pentane. So this is pentane. Pentane, and it has 1 group on the chain. It has this bromo group right there. We want to start numbering closest to that group. So that's 1, 2, 3, 4, 5 carbon. So this is 2-bromopentane. 2-bromopentane. So by adding the addition of hydrogen bromide to pent-1-ene to pent-1-ene, we were able to come up with a reaction mechanism to get to 2-bromopentane.